To start, press any key. Where's the any key? Woohoo!
Pythagoras of Samos is often described as the first pure mathematician. He is an extremely important figure in the development of mathematics, yet we know relatively little about his mathematical achievements. Unlike many later Greek mathematicians, where at least we have some of the books which they wrote, we have nothing of Pythagoras' writings. Pythagoras gained his famous status by founding a group, the Brotherhood of Phytagoreans, which was devoted to the study of mathematics. The group was almost cult-like in that it had symbols, rituals, and prayers. Pythagoras believed that numbers rule the universe, and the Pitagoreans gave numerical values to many objects and ideas. These numerical values, in turn, were endowed with mystical and spiritual qualities. Pythagoras is best known for his theorem that shows a relationship between the sides of a right triangle. Although he is credited with the discovery of the famous theorem, it is not possible to tell if Pythagoras was the actual author. The Pythagorean theorem states that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. The hypotenuse is always the longest side of a right triangle. In the formula, A and B are the legs of the right triangle. C is the hypotenuse, or the longest side, of the right triangle. This formula shows the relationship between the three sides. A squared plus B squared equals C squared. This relationship has been known since the days of the ancient Babylonians and Egyptians, although it may not have been stated this explicitly. As you have heard, the Pythagorean theorem is a very old concept, but does it have applications in our lives today? The answer to that question would be a definite yes. A close examination of this sailboat shows a rough example of a right triangle. Notice how the rope extends from the top of the mast to the front of the boat. If we know the height of the mast, A, and the distance from the mast to the lower end of the rope, B, we can calculate the length of the rope C using Pythagorean's theorem. First, you need to substitute the measured values into the formula A squared plus B squared equals C squared, so that 20 squared plus 15 squared equals C squared. You now need to square the measured values of A and B, which will give you 400 plus 225 equals C squared. Next, add the two values together so that one number will equal C squared. 625 equals C squared. Finally, solve for C by taking the square root of each side. The square root of 625 is 25 feet. Using the Pythagorean theorem made finding the length of the rope much easier than actually measuring the rope by hand. Unless, of course, you like climbing sailboat masts. Here is an example of a wheelchair ramp at a shop in Kima. How high does the ramp rise? If the length of the ramp is 11.5 feet, and the slant of the ramp is 12 feet. When you assign these values to the formula, remember that the longest side is always C. The other values can be assigned to either A or B. Your formula with the values in place is A squared plus 11.5 squared equals 12 squared. Again, our first step is to solve the known values, which gives you A squared plus 132.25 equals 144. To solve for a squared, you must first subtract 132.25 from both sides of the equal sign. Now, a squared is equal to 11.75. Remember, to find the value of c, you must take the square root of 11.75, which will give you approximately 3.4 feet. So the ramp rises to a height of 3.4 feet. These numbers were used strictly for this example. In reality, the length of the ramp on the bottom would need to be a minimum of 12 times the height of the ramp. If you have ever gone shopping for a television, you may have noticed that there are several types and sizes available. For example, you can purchase a television that is 13 inches or one that is 62 inches. But what does that measurement really mean? The size of a television screen is based on its diagonal length. You can find this length by measuring the sides and bottom of the screen and substituting those values into the Pythagorean Theorem. Take a look at this big screen TV. The side measures 28 inches. The bottom of the screen measures 49.5 inches. We will use these two measurements to find the diagonal C. When we substitute our measurements into the formula, we get 28 squared plus 49.5 squared equals c squared. As in the previous two examples, the first step is simply to square the known values, such that 784 plus 2450.25 equals c squared. The sum of these two values, 3234.25, will equal c squared. Finally, solve for c by taking the square root of each side so that c equals 56.9 inches. This particular television is listed at 57 inches, which is fairly close to the 56.9 inches that you calculated. Now that you understand these examples, go out into the world and discover other uses for the Pythagorean theorem.